through the Connecting Europe Facility Program. Its objectives are to advance towards the standardization of processes and the application of Industry 4.0 technologies in port container terminals. Port terminals use a wide variety of equipment, being very common the presence of different models and manufacturers. The interoperability with the rest of machinery presents difficulties because they do not share common communication standards and formats. iTerminals 4.0 proposes the creation of a standard and universal language, named TIC 4.0 Semantics, to eliminate these barriers and facilitate the transmission and sharing of operational information. TIC 4.0 Semantics is designed to facilitate the application of big data, artificial intelligence, and other Industry 4.0 technologies. In container handling operations, it is essential to have available tools to perform these tasks in a smooth and synchronized way, reducing cycle times and detecting operational bottlenecks. Big data is paramount for developing a new management culture based on the availability of real-time data-driven decisions, detecting inefficiencies in advance, and creating a dynamic virtual image of the operating process in real time. A big data architecture applied to port operations management should include, among other components, the following: data collection, edge computing, visual programming, data fusion, data visualization, real time. Big data allows to obtain greater visibility of the process in real time and helps to anticipate operational problems such as non-productive times, congestion, operational overloads, etc. The iTerminals 4.0 project has enabled the upgrade of a large variety of port machinery by incorporating IoT gateway devices on board such equipment. These devices allow the transmission of operational and telemetric signals via internet for their reception, processing, and visualization in big data platforms. The main port machinery involved in the pilots are STS in the ship berth interface, RTG, SC, and TT in yard operations, RS and ECH in yard gates. In this context, different pilots have been developed in European container terminals in the ports of Malta, Antwerp, Dunkirk, Montoire, Thessaloniki, Sines, and Genoa, testing TIC 4.0 semantics under different operational use cases. This set of pilots has allowed to validate from the technological and operational perspectives the feasibility to implement a standard operational information exchange scheme. iTerminals 4.0 will help European ports and port terminals to adopt Industry 4.0 technologies. It will also reduce the associated costs, making European port terminals more flexible and competitive. Thanks to iTerminals 4.0, both port equipment manufacturers and terminal operators have a new standard. It will allow harmonizing criteria when designing and incorporating new equipment into terminals, making them compatible and interoperable with existing units.
Well, I hope that you hear me well. It's 6 minutes past 3 p.m. here in Spain and Central European time. And well, after this introductory video, I would like to wish you good afternoon to all the attendees to this final conference of the Innovation Action iTerminals 4.0. And on behalf of the European Consortium, which integrates this project, I would like to give all of you our warmest welcome. And especially to those colleagues joining from outside Europe. We have many representatives and colleagues of the industry from North and South Latin America, also Asia and Africa. So thank you all for your time today. My name is José Jiménez. I am Port Logistics Director at the Fundación Valencia Port, which is the Innovation and Training Center of the Port of Valencia in Spain. And before continuing, I would like to inform you that this meeting is being recorded. So it's just for public dissemination. And we kindly ask you to mute your microphones and cameras to facilitate the smooth running of the presentations and videos that we will show you. We have prepared a lot of audiovisual material, and due to the bandwidth, it would be better if you all can switch off your cameras, and we thank you for that. And also, we also invite you to leave your questions and comments in the chat box of the meeting, because we have reserved some time in the middle and at the end of the conference to answer questions and to discuss any aspect that you consider important. Well, I should start giving to you some context about the iTerminals 4.0 project. This project is an action co-funded by the European Commission through the Connecting Europe Facility program. And its main objective has been to create a new framework for the implementation and the deployment of digital standards in the port terminal industry. These standards are very much related to harmonizing logistics processes and the way that the information associated to those processes is transmitted and exploited at port terminals. And during the last years, a relevant group of key actors in the sector, port operators, port equipment manufacturers, and digital solution providers, have joined forces within the umbrella of the International Association Terminal Industry Committee. And this project, iTerminals 4.0, represents an important milestone of the effort done during this last year in this field. Today, we will present to you the results achieved in this project and how these results can be scaled up to the sector. But before starting, I would like to introduce Mr. Boris Wenzel, who is the co-chief executive officer of Gilport Holding and president of TIC 4.0 Terminal Industry Committee. Boris, thank you very much for being with us today. I give the word to you so that you can also welcome our audience.
Thank you very much, Jose. So it's a real pleasure for me to be here, and I see we have a lot of attendance. So it's nice to see how standards are getting the industry interested, or maybe even excited. Let me give you a few words about TIC 4.0, because I think without TIC 4.0, there is no iTerminals 4.0. This is the way to look at it. And we started TIC 4.0, as some of you know, a little bit accidentally following a conference I gave in 2018, where I was reflecting that the certain frustration that if there are no standards, we are not able to actually compare apples with apples, and we're not even talking the same language. So it's actually very difficult to innovate. And this led actually to a lot of interest, where we started to have some meetings. And the interesting part in these meetings is, I think, and this is what makes it a bit unusual, is that it was meetings among competitors together with our suppliers, who are also among themselves competitors. And we have, we've been in fact, trying for a while to figure out what to do and how to work together towards this lofty goal of developing standards. And this is when there was this opportunity of iTerminals that came about in the form of an EU project, which we thought we can fit as a project to support the work of TIC 4.0, and to actually, most importantly, bring about a real life proof of concept that the standards that the TIC 4.0 would be working on could actually really work. Okay, and this is we see today.
Just sorry to interrupt you. Maybe could you turn on your camera?
Yeah, sorry, I didn't do that. Okay, but I think people are happy to see you otherwise, huh? But okay, let me. All right, here it is. Oh, no, I'm sorry. I think there's a problem. Okay. I see a black screen, huh? Never mind. Sorry about that.
We see a black screen, but okay, no worries. Yeah, no worries.
I would have to restart my computer. No, I continue. So iTerminals was really the 4.0, the opportunity to demonstrate that the standards which are being developed by TIC 4.0 actually work and are as useful as expected to be. So we have as an association grown very much. Today we are more than 40 members, and we have in fact most of the leading terminal operators and their suppliers working in collaboration to develop these standards. We had already 5 or 6 publications, and the project of iTerminal in fact comes as a very, as I said, very strong addition to this in demonstrating that these publications is not just theory, but it actually works. And the objectives that we had with TIC 4.0, which is to actually, through standards and in particular data standards, promote a rapid innovation that can take advantage of 4.0 technologies that are today available. Undertaking, as many of you know already, undertaking data-driven projects without standards is of course possible, which means you create your own standard, but it's very risky and expensive. And we believe that the future should be a copy-paste, plug-and-play future, which means that, and this is, I think, what you will see through the demonstrations today of iTerminals 4.0, working with any system you want, connecting it to any equipment you want, and it should be done in an efficient way without having to retest and reconfigure everything, because all of your equipment and systems are what we now like to call TIC 4.0 ready. So we have recently even developed a logo to promote the use of these standards. I hope you will start to see it appearing with many companies, whether suppliers or terminal operators in our field, which is the We Talk TIC logo, which in fact identifies a willingness and a readiness of players in the industry, suppliers or operators, to work with these standards, which would allow them to realize what has been tested in these pilots. So I would like to finish by saying that the TIC 4.0 language is of course free for all. This is not something which is sold, just to avoid any confusion, and the work which has been prepared under this iTerminals project is also going to be shared, of course, under the conditions of the EU funding. And I would like to actually thank CINEA and the CEF program for supporting this project. I think you will see from this presentation that from all aspects it can be it's considered as a successful case of applied innovation in the port sector. And there are tangible results which will continue to live and actually expand beyond the end of the project. I know already that Mr. Blanquer, who's been a leading force behind TIC 4.0 and behind the iTerminals project, and who is also has implemented in a few of the CMA Terminal Link sites these pilot cases, is actually going to expand that to probably most of the terminal of CMA terminals. So it just shows how here the EU funding has been, in fact, providing a very useful support as the concept was analyzed, and to make it a proof of successful application, and as it can now be replicated easily. So I think this was a long enough introduction. I'll go back to you, Jose. And I'm really sorry, I actually cannot stay during this presentation. I have a too busy schedule today, so I hope you'll forgive me. But I wish you all a very good presentation today, and hope we can catch up maybe at some point in a future conference such as TOC. And in the meantime, please also feel free, if you are convinced but you will hear today, to visit the TIC 4.0 website, where you can get more information if you're interested to join, or you contact Jose, because as some of you maybe know, he's actually the Secretary General of TIC 4.0. So the easiest way is to contact him then. Thank you very much.
Thank you very much, Boris, for this welcoming statement and for your presence, even though of course, you have a very tight agenda today. So really much appreciated your words. And well, now it's the moment to start with the first block, the first session of the conference, which is dedicated to present examples of how digital standards and their application through Industry 4.0 technologies can help to solve current operational problems in the industry. Again, we invite you to leave your questions in the chat box. By the way, we have shared the agenda of the meeting also in the chat. You could see a couple of images, so you can follow the different presentations that will come. And at the end of this first set of presentations, we will have a roundtable where we could ask the speakers and debate about the results presented. So the first example refers to the flagship container terminal of CMA CGM Terminal Link, located in Malta Freeport. And for this session, I would like to introduce our first speakers. Francisco Blanquer, he is Senior Innovation and Development Manager at CMA CGM. Hein Chekuti, Operations Development Manager at Terminal Link Malta Freeport. Ángel Martinez, Head of Products, Maritime and Terminal Solutions in ProDevelop. And Michael Kugler, Consultant at Real-Time Business Solutions, RBS. So, gentlemen, the floor is yours, and please go ahead.
Thank you, Jose. Thank you, Boris, for the introduction. Yes, no doubt. This is the field test for TIC 4.0, and also the contrary. Thanks to iTerminals, we were able to really move forward TIC standards in a very high speed. We did it almost without resources, so was a really good job. Okay, let's start and introduce what we did with TIC. What are the results? What has been our experience, and in fact, what are we going to do in the future? So basically, the aim of the project is to demonstrate the value of digitalization, and we will see now what is digitalization. Basically, we are going to apply IoT and big data technologies in several terminals. In this case, we are going to see the example of Malta. We are going to see how we resolve the problem of the standards of the language, how we resolve the problem of the technology, and what is the final result. I will go really fast over the main concepts because I know it's very boring, but it's really important. You have to understand that in our sector, the process by itself is very inefficient. And we did it. There is a reason for this, because basically we have to do it very cheap. The CapEx have to keep it very low. Why? Because let me use the pointer, because the time our equipment is working is really, really low. We don't have a continuous process where the machine is running 24/7. So we only work when we have cargo. So this percentage is really low. And when the machine is working, the percentage of time that is really working and not idling is also very low. At the end, we don't take any advantage of the equipment. It's very low efficiency the way we use our equipment. And that is okay if you don't have too much traffic. I mean, your main objective is reduce CapEx. How we can improve this number? But basically, you have two ways. Or you do a full automation to have this much higher, but this is going to be very low. Still, you don't fix this problem. Or you use data to improve this figure and also this figure, both of them. You can fit much better your facility with a lot of data. If you have a lot of traffic, automation is the way to take, no discussion. But 90% of the terminals are not full congested. So for most scenarios, the best solution is just use data. So what is the problem of use data? That is not so easy to use or to get value from data. And the experience is in the past, a lot of people tried, and in fact, we failed. We use only a very small percentage of data. What happened? When you want to use data to improve any reality or to manage or to understand any reality, the reality itself is very complex. And what is a reality? Reality could be a machine, the behavior of a machine, could be a person, could be a process. Most of cases we have processes, could be a terminal, a complex system. That is a reality, what we call a subject in TIC. And whatever is doing, this is the time. This is one process, for example. Whatever is the process you want to express is complex. You have a lot of parameters and a lot of things that are happening every millisecond. And finally, you have one important event, that is when you finish one job, basically, when you finish one objective, and you start another one. And if we think in the discharge of a container, that is, for example, this is this example in STS, in fact, if you want to know absolutely everything, you go to the reality, you have a lot of things that basically are things that are happening all the time and then ungiven, things that are happening all the time and then ungiven. And this is the reality. What we have today, basically today, when we say we have a lot of data, we have just this. We have moved on in the TOS. That is what we have. Okay, are we going to do a fantastic digitalization? And then we have this, the job stepping, no? So first step done, second step done, third step done. But this is not enough to do a continuous improvement in all the aspects, because we don't know, we know that this is 2 minutes, but we don't know if this is good or bad or what happened in the middle. We just know that this step took 2 minutes. We need something else. And what is that? Is this. We need a high resolution data between events. So we need the status. What is happening between events? This was just almost impossible 10 years ago because the technology was not ready. But today, thanks to big data, we can do this. We can have not only the events, but a lot of data in between. Why is this so important to do this? The main goal of full digitalization or the big data technology in a terminal is to represent the reality, whatever is the reality, it doesn't matter which one. In this case, it's the job stepping of the TOS. And the IoT and big data, so the shared reality, the machine behavior, to be able to compare both of them. So if you have not only the events, but also the status of every single process or equipment, you can mix and compare and verify one against the other, and not only one by one. Imagine here 10 processes running in parallel. You can go and detect when something doesn't go as should be, because our main objective is to improve, of course. In this example, you have the log off in the process, then you have log on but with no order, then you have to the yard to collect. We have a machine that is, in theory, should go to the yard to collect. Then it's a yard to collect, to vessel to drop, at vessel to drop, and no order again. This is a very simple example of a cycle, of a move of a cargo in a terminal from the process point of view. But in fact, what is doing the machine? Okay, the machine was off, then on, then was driving, then idling, then driving, then again idling, then driving, idling, driving, idling. This by itself means nothing. But when you put together the reality and the process, and you do it second per second, if not, you cannot do. Imagine hundreds of machines with hundreds of processes. You can identify when something, for example, when the reality is not what should be. So in this example, we have an alarm because this terminal tractor, for example, should be going to the yard to collect, and in fact is idling. If you should be working to the yard to collect, driving to the yard, why are you idling? Okay, 1 minute, 1 second, 2 seconds is normal, but 1 minute, 2 minutes, 10 minutes, why? Then you have an alarm. This is the kind of things we can do with big data. Imagine a lot of examples, tire pressure or monitoring. We will see a lot of examples today that we are doing this with many, many, many things. What it is and what should be doesn't correspond. And then we identify we have a problem. Thanks to big data, we can do it in real time. Thanks to big data, we can aggregate how much is this in real time. Thanks to big data, we can sum all these not conformities during the last hour, last week, last month, last year. This is the power of big data. But for this, we need a language because the reality is really, really complex. And then that language have to be able to do big data. This is the definition of big data for us. So basically in your database, you manage up to 3 million registers quite well. Typically it's much less. But in big data, we have 10,000 million. And we need this. If we don't have this, we cannot do the previous example. We have to do it in real time. All the data have to flow in real time, but we need a language able to do this. Have to be ready for this, no relational database. Also, the language have to be able to represent any reality. That means present, past, or future in the reality. Yes, we have to be able to talk about the future, because if not, what is the point of artificial intelligence? Artificial intelligence main application is about the future. How are we going to express the future? How are we going to express the events? Events, no problem, but instantaneous, the status, we need a language able to express the events and the status, and able to express also the aggregation of status or events, and put all together in a virtual object. A virtual object is just a register that represents an object, a reality, okay? That is TIC. So not only have to have these qualities, but also have to be understandable by humans. Now we have like, I made the figure the other day, 8,000 realities for the container handling equipment and like 4,000 for processes, for the TOS. So there is no human in this room, no person in this room able to learn by heart 8,000 acronyms, like ETA. Okay, ETA is one, ATA is another. And when you have 8,000, are you able to learn by heart that? It's just impossible. So we need a way to express the reality that have to be understandable by machine and humans. And that ontology is the ontology of TIC. The ontology of TIC is based on of a human sentence, on grammar, that we have the component that is the subject, that is the one that made the action, the concept, that is the action, what is or what does the subject, the observer property, that is the magnitude of this concept, this verb with this subject. That means the magnitude is the status, the duration, the counter, the timer, the distance, the speed, the flow, whatever you refer of this, what is or what does this subject. The point of measurement is important because we need to define, okay, this magnitude, where are you measuring? At the input of the equipment or process, at the output, so it's an exit of the process or equipment. Also about the time, is something actual, is right now, is a real data right now, is something that is going to happen in the future, and we have many futures, or is something that happened in the past, but I don't know exactly when and where, because I know that 1 day ago something happened, were no container in the yard, and now there is a container for Probably I made one move, at least one. This subject concept of several property and point of measurement defines perfectly, without possible error, one reality. And then on top of this, we put the unit. The value is the sum of this. And we also typically, for one value, one numeric value, you can make a scale. But the meaning is the same, but we change the scale with the unit. How looks, well, you have everything is public. You have that in this link. TIC 4.0 is public. It's done by the members that we are competitors, so everything is public. How looks like it? This is like a sentence. If you want to say how many boxes output, get out actual real data counter number of, you may move and unloading in a cycle of the queue of the terminal. This is the number and looks like this. This is an example for terminals. You can have many subjects and sub-subjects, many combinations of actions, of concepts, and you can change the unit, no problem. And this defines in a unique way the meaning of this number, no confusion. But you can use this as a flat, in an email, talking, or in a digital way. This is the standard in digital format. So these are two messages, independent. This for one time stamp. This message contains two machines with the ID of the machine. The power source information is true. This is on this power source, and with the spreader metadata. And we have two different machines in one message. Here is one message per timestamp, but you can represent also that in a hierarchy way, in a typical XML or JSON format, exactly the same. And we have a direct translation between one and the other to express exactly the same. And this looks like something like this. This today, this message, this data model. We have one data model published for machines, another for a process, for DOS. We call it DOS because it's the main software that drives the process in the terminal. And it's a monster. We are talking about 22,000 lines in the case of the CHE, and 18,000 in the case of the TOS. And you see, when you expand one of these, this is the spreader example, you have a lot of things inside. It's very human readable, very easy to explore, very easy to understand where is the data, what is the meaning of the data. And that was one of the main goals and the main output of iTerminals. So, very nice. Now we have to take all this theory. By the way, I'm the chair of the operational council of TIC 4.0. It's a lot of work. It's like the technical director, and I like a lot. TIC is really useful. How we apply all this theory in the real world? Now we need the technology. So I will give the floor to Angel to present from ProDevelop to present what they did in Valencia. From Valencia in Malta.
Thank you very much, Curro.
The floor is yours.
In theory, I have requested the control. Can you confirm that is correct? Can I? Okay. No. Can you see my screen, right?
Yes.
Thank you very much, Curro. Well, thank you very much, Curro. Thank you very much, Boris, for such a nice introduction. One of the things that I would like to highlight, and I try to be quite brief, is that the importance and the rationale to carry out such type of projects that, like iTerminals, is that, as Boris said, in theory, there is no difference between practice and theory. But as all of us really know, in practice, there is. when you try to define everything, carry on desktop research in front of your laptop with a mug of coffee, etc., everything works. Everything's totally fine. But when you try to deploy that in a real live terminal, let me be a little bit unpolite, but shit happens. So this is the real example about how it's possible to deploy and to demonstrate the value. Because as Curro said, the magic of such kind of projects is because there are a lot of competitors. We are trying to cooperate in order to develop and design solutions that talk in a common language that everyone really understands. And that's the magic and the for me, in my humble opinion, the most impressive outcome of such kind of projects. Well, Malta is, let's say, the lighthouse of the Terminal Link container group. As you probably know, Terminal Link is one of the major players of the industry, and such kind of proof of concepts enable them to demonstrate the validity to take the better decisions with less uncertainty, because we are able to put a lot of small devices, edge computing and IoT devices distributed in the yard, in the STS, as you could imagine, in a lot of cranes. We are able to put such information in a sorted way, which is really understandable, not only for ProDevelop, in our case, because we are a technological provider, but for the whole staff, which are part of the terminal container group, plus third parties that could collaborate and be a kind of a stakeholder, which has nothing to do with ProDevelop. That's the magic. And the most important point is that is possible because all of us, we are, let's say, TIC 4.0 compliant. We really understand which is the magic. According to our understanding, it makes no sense today to try to make, let's say, prisoners, or because we would like to cooperate with them, with the terminals. And our intention is to, because the data is not owned by ProDevelop. The data is, or not should not be owned by a third party. The data is for the terminal. So we need to be completely sure that the data is persistent in a way that they are able to exploit such kind of data without our intervention, okay? So the point is that how this normally works. There are a lot of vendors in a real-life terminal. There are different vendors, there are different manufacturers, there are different types of versions. We are able to, the first step is to deploy and install a device which is close or inside the crane, which is gathering data in real time, in raw. Then we try to translate such raw information into the common language, which is TIC 4.0 compliant. Then such information is persisted and sorted in a way that could be, as I said before, exploitable from ourselves. I mean, as a company, who develop and design software solution, by the staff of the terminal, if just in case they have the knowledge to develop their own solution. We are going to see later on a very good one example carried out by your colleague Hein, and also to involve and put at the disposal of a third-party company. We are going to see as well a new example at the end of this presentation by your colleague from RBS, which gives the opportunity to the terminal to require such kind of services depending on the third party who is the best to play such kind of action. We have prepared for you, in order to be a little bit soft in the presentation, a small video. It only takes 5 minutes, which demonstrates or try to see you which has been our playground during the iTerminals project in order to digitalize the lighthouse of Terminal Link. I'm going to try to play the video. Please, Curro, correct me if you are not able to see the video playing.
The volume is a little bit high. Can you reduce?
It's Curro. It's Curro flying to Malta. Thank you very much. I think that you have enjoyed watching the video in the same way that we have make it possible. Just to sum up and to conclude my intervention and to pass the floor to my colleague Hein, is that as Curro said, the use cases and the opportunities having big data in your terminals is completely endless. So collaboration from now onwards is not an option, and iTerminals, projects like iTerminals as a standard like T4.0 is the only way to go forward. So thank you very much for attending and having us the opportunity to be involved. Curro, if you could recover the control.
No, now is Hein. Hein, please take the control and the floor is yours.
Thank you very much.
Thank you very much. So greetings from Malta. My name is Hein Tuti, and I'm responsible for the innovation and development at Malta Freeport. So we hear some nice words about the flagship and the lighthouse of terminals. So thank you very much, guys. What I would like to demonstrate in the next couple of minutes is the practical use of all this overwhelming technology, diagrams, data, IoT. So we have made the first attempt to use this information to make it meaningful, especially for our operations people. One must understand that when you are dealing with novel technologies such as this, especially for an industry that sometimes shows a little bit of lag in adopting latest technologies, there is quite a learning curve and there is a learning process for us gentlemen and ladies to absorb this information and to absorb these technologies and start using them in practical life. After the preparation of all the infrastructure, which was a huge challenge, we sat down and we started to digest all the wealth of information that was presented to us from the big data platform. So imagine looking at the stars and seeing all those millions of stars and trying to see what and how to understand, and it is a very complex process. So after sitting down, we wanted to harness all this wealth of data coming from different areas, because the big data platform obviously is not operating in isolation, but it is operating in contemporary with other systems that the terminals are normally using. We have already mentioned the TOS, but there could be others, like systems, for example, like message queues coming from third-party vendors, and other types of systems that need to be integrated together so that the terminal, so that the end user can make the best use of this data. So after brainstorming and a lot of discussions, and not only one coffee, I think it was a 40-foot container of coffee, we wanted to see how we can visualize. In the previous presentations, we mentioned one of the outcomes should be data visualization. And that is very important because data visualization gives you the power, gives you a different perspective. But looking from Francisco's presentation, all those registers, and this is the result, a visual result of those registers put together. So what we have developed as a first pilot project, also internal to Malta Freeport, a system that is demonstrating in real time all the operations, all the assets that are working together in one screen. And this was a huge breakthrough, because it could not be done before with the traditional technologies. So after we managed to understand and harness and start collecting and managing the data, then we started looking at how to add operational value to this information. And we started with the horizontal transports, which in Malta we are using terminal tractors that are manually driven. And we wanted to understand where the weakest points or the weak points in operations are, and where the human being, like for example, operation supervisors in the yard, cannot improve his performance. Therefore, the technology must come in and play that part. So just the slide that we are viewing now is just one small example of what we have done. In this case, we are seeing...
I cannot see the slide. Hein, are you moving forward the slide?
Yes, I went to the... Okay, let me...
Oh, something... Ah, no, it's me. There was a problem with my slide. Sorry to interrupt. Please go ahead.
So in the slide, we are giving an example of a mission for a terminal tractor, and the system is detecting the route of how that mission should have been accomplished, and the actual route, which is depicted in blue, of how the driver decided to undertake the mission. Now imagine if you have a person viewing the track, but unable to know the origin, the destination, the path taken, and this cannot be done simply by the human that is supervising the operation. So it is where all this data comes in to assist our operation supervision to detect anomalies that before, even though one could feel that there were deviations from how to execute the missions, it was difficult to understand and visualize what was going on. With the strength of all this data, we can now also try to understand a number of operational issues that we used to have. For example, drivers that are driving too slow, drivers that are stopping in areas where they shouldn't be stopping, drivers that are taking wrong directions. And we are developing slowly all this knowledge into the system, only possible because there is the data that is now available. And the data, as I already mentioned, is coming from the big data platform, from the TOS, and from other systems that the terminal is already using. But let's again take, for example, the visualization of the assets related to a key crane. So Francisco on the video had shown a key crane that had no tracks. With this tool, I can now also understand exactly where the tracks that should be going to that key crane are on the terminal, and I can take actions next to real time. You can also detect other anomalies through this operational view that, as I mentioned before, were very difficult for the naked eye, for the person, to try and understand the reason for such problems. For example, here I'm giving also an example of a truck that was doing a mission traveling at 8 kilometers. And this is detectable only because we have second by second information that is coming through our systems. Thank you very much. I hope that has been of influence and that of practicality, a small demonstration of what we have been doing in Malta with the use of TIC 4.0 and the iTerminals project. One last thing, for us, this is only the tip of the iceberg. As happens normally, you start deploying the technology. Once you get it into mainstream, once you start using it in the mainstream processes, then there's no going back, and there is the only way forward and advancement. Thank you very much, gentlemen and ladies.
Thank you very much, Hein. Just to tell to the people, we don't see a video of this software running. In fact, it's an IP of the terminal, but everything is in real time. All the tracking, the positions, everything is running in real time. You don't have to wait anything to know where should go that machine, that terminal tractor, and what is the optimum path. It's a very good piece of software, and it's just it's doing in-house. It's very impressive the way you use the data. Now with this in mind, so wow, very impressive. How should looks like the future? So we ask our partner RBS, please draw us how this should be from a super expert software provider. And that is the mission of Michael. Please, Michael, the floor is
Hi.
yours.
Hello. Thanks, Kuro and Hein, for this fantastic introduction. And hello to everybody out there on the devices. So my name is Michael Kugler. I'm a consultant for simulation and TOS implementation at Real-Time Business Solutions RBS with our affiliate company, Aquinet. And we have been doing a pilot in the realm of 3D visualizations and digital twin modeling, also here with Malta Freeport. Yeah, starting off with a little showcase. This is Malta Freeport, but not as we have seen in Kuro's video in real life, but the digital twin version. And this is one major part of what we have been doing and actually the basis for everything we're doing with this big data. So the question is, what is the business case? As we have already heard from Angel and Hein and Kuro, Terminals Malta Freeport is already gathering big data on its cargo handling equipment and doing this in a TIC 4.0 compliant IoT platform. Now we as RBS EMEA and Aquinet, together with Terminal have placed a pilot on top of that in the stream of improving the operations efficiency. And the concept of this pilot is to have a 3D visualization in a digital twin terminal model of Malta Freeport, which is connected to the IoT by a TIC interface. Now the question comes to mind, what is the purpose and the goal of a 3D visualization? As we have already heard, just having big data does not do the job alone. The issue is you need to represent this data in a valuable way. This is imposing two major challenges. One is, how are you integrating this data? So on the one hand, you have the IoT data, but on the other hand, you have your process data from the TOS. And the second challenge is, how is this data then visualized so that in the end it creates value to the end user and that it is beneficial to the user so it will be used really. Yeah, as a first step, what we have been doing, and also from my feeling in the recent years, everybody is talking about digital twin modeling and digital twins in general. But yeah, here on the left-hand side, you can see how this actually looks like. So this is a snapshot from our ChessCon toolkit, where we are actually building a digital twin. And then this is outputted from ChessCon as a 3D visualization, what you can see on the right-hand side. So this is the full model of the terminal, including gates, road network, all the stacks, all the equipment, but here, of course, without containers. Now, yeah, I see somebody asking about the slides. Can everybody see? I can see the slides.
Yes, I can see the slides.
Okay. All right, yeah. When analyzing the business case further, the question was, what functions are required to support the operational stuff in decision making in this 3D? This led us to the case that we need a good kind of data representation. And thereby we have implemented two major functionalities, which is on the one hand, a color coding algorithm, which we will see also in a small video afterwards. So which is changing the color of the equipment based on what it is actually doing, and the functionality to hide and show objects so that the user can focus on the object of interest and also click on an object to highlight additional telemetric data. Then thirdly, we had to think about how are we making this data available to the user. And there we have implemented two major modes, which is firstly the replay mode, which allows the user to replay a shift from the past to identify what has happened in the past and possibly open up room for future optimization. And secondly, a digital live mode, which allows you to see your terminal as a digital twin model. And thirdly, in this, it should be highlighted if there is a conflict between process data from the TOS or IoT data. Okay, I would say enough from the talking from my side. Now I'm going to start with a little video.
Wow.
All right. With that being said, thanks a lot for your attention. I think everything has been said and summarized, and yeah, I would now like to lead back to the next speaker, to Kuro.
Thank you. No, thank you, Michael. Our job is done. Now I think everybody have a clear vision about what is this of big data and where are we going to. Jose.
Yes, okay. Thank you guys for this impressive deep dive in the in how you have applied in real use cases in a real scenario, cutting edge Industry 4.0 technologies. It's been really nice. All your videos and demos. Thank you very much. And I keep inviting all the audience to leave any question that you may have. We will have time later on to recover those questions and of course clarifying them. But now, then, yeah, we will show. Well, the conference is being recorded, and we will share the slides. Of course, all this material will be made public. So then we move to a second example of digitalization application of digital equipment telemetry and the standardization of this data exchange by the hands of PSA Antwerp Container Terminal and Cranes, who are going to present us a use case focused on yard equipment, a specific yard equipment that is being used at PSA Antwerp. These yard equipment are straddle carriers, and how these straddle carriers can be connected to also a big data platform available and on that facility. So I would like to introduce the next participants, Dani Akari, who is a platform engineering manager at PSA Antwerp Container Terminal, and Samsa Oja, product manager of digital services at Cranes. So same way of working, same methodology, guys. The floor is yours, and I leave it to you.
Very much. I just wanted to start by saying the iTerminals for us, it was like an opportunity to take a leap into the future and like apply a new like industry standard. We found that data is key and that standardization is crucial. And for that, we developed like a quick clip that hopefully you'll enjoy to watch. And like it explains everything that we tried to do. I'll share my screen now if that's okay, and please let me know if there is any issues.
Standardization is what enables the global adoption of novel concepts. Industry 4.0 data standards such as TIC 4.0 unlock actionable insight with greater ease. In aggregate, container ports are the beating heart of the global economic engine. The adoption of Industry 4.0 standards assures an era of enhanced cooperation, greater intercommunication, and profitable trade routes, all while promoting environmental causes and reducing our energy and carbon footprints. One of the biggest challenges continues to be harnessing and exploiting big data. In the quest for interconnection and smart automation, the objective was to stream the data to where it could be best utilized and have the greatest impact. It was in operations that data could be best converted into actionable knowledge. Machine-generated data should be aggregated, processed, and showcased on a dashboard that would help operations gain key insights into their performance and enhance their situational awareness with real-time updates regarding location, fuel levels, tire pressure, engine temperature, RPM, etc. To expand from data streams to a platform where data enables predictive analytics and the application of artificial intelligence along with real-time KPI reports, Antwerp Terminal Services developed IMP Asset Monitoring Platform. IMP monitors important metrics that have a direct impact on the equipment's downtime, diagnostics, and performance. In collaboration with Kalmar and Cone Cranes, suitable newer straddle carriers were selected to house the installations for test hardware. The overall IT infrastructure was defined, and the variables from the datasets were transmitted by MQTT in compliant JSON TIC 4.0 format. Initial datasets such as spreader, hoist, and power source were monitored as those, at the time, were already defined in TIC 4.0. They were also some of the easier ones to start the translating process with, and contain variables that would be easily testable. This was later expanded to include further data such as health, activity, and drive datasets, as they respond to use cases within operational efficiency, safety, and maintenance. The IMP platform allows for real-time visualization of equipment status and indicators during operational time, and for the creation of daily reports. Through both real-time monitoring and reporting, maintenance can be prioritized and scheduled, enabling the different teams within ATS to work together seamlessly and timely. IMP takes its relevance from the fact that reliable and active equipment translates into operational efficiency. Preventive maintenance reduces downtime and the cost of maintenance over time. IMP allows to visualize key indicators from multiple vehicles simultaneously, which facilitates decision-making, planning, and cooperation. In the case of straddle carriers at PSA, drivers can now coordinate with maintenance and repair teams based on shared and corroborated information. This way, equipment can perform consistently during operational time and avoid major malfunctions that could compromise personnel safety. By ensuring the optimal condition and performance, IMP helps facilitate sustainable and appropriate usage of resources. From energy consumption to spare parts and fuel, making operations more sustainable by reducing its carbon footprint has also been a goal and a result of the IMP project. Equipment manufacturers provided modified circuit diagrams, integrated new hardware, and developed relevant software upgrade kits to be installed. Initial testing on dataset variables was performed and further validated in an operational setting in collaboration with PSA. The overall software was developed with modularity and scalability in mind, and would be applicable in the future throughout a newer fleet of carriers. Such solutions will continue to be developed since they are a critical part of the present and future of the industry. These are exciting times for historically analog industries. Digitalization projects such as AMP deliver impactful change and open the doors to new paradigms of optimization.
Thanks, Danny. Maybe I'll share also a few words from Konecranes side. So greetings also from cold and snowy Finland, so to say. But I think the video kind of encapsulates and recaps quite well the journey we had together with PSA under this iTerminals and TIC 4.0 umbrella. As mentioned also in the video, we developed the software in a scalable way, where it could be then also easily adjustable towards the other newest trailer carriers as well, and essentially would be working like a sustainable product would be working. We have also started to extend even further the interfacing capabilities overall in terms of the data that is already being provided, and also we intend to extend the overall TIC 4.0 software capabilities towards many of our other equipment as well. Similarly, also in a scalable and sustainable way. From Konecranes' point of view, we definitely see huge potential and value as well in such defined standard that has now been put in place with TIC 4.0 and the overall commonly agreed language between the different OEMs and the different terminals. And definitely we see this as a path also forward within the whole industry. We can also already see some of the benefits, not only that has been presented now here and will be presented in the further, let's say, slides as well from others as well, but also towards the future. Definitely see the value that we now can. We have gotten the examples in operations also partly also in the maintenance sector, and also naturally we want to be part of that journey as well, going towards the future as well. But all right, I think that is a short recap from our side, and naturally, as also mentioned, that if you have comments and questions, feel free to put them also in chat, and then we can also separately try to answer those on chat, and then we have the Q&A or the roundtable session, which we can also try to get some of those answers as well.
Thank you very much to both Danny and Samsa. I think we have seen so far two different models of data exchange involving different type of equipment. It could be seen that this is the same thing, but it's not. In fact, it's very different from using TIC 4.0 language or adapting it to jar equipment like RTGs that we have seen in the case of Malta. And in this case, we apply the same standard to a totally different equipment, a straddle carrier, jar equipment, which has also a very different role in the process of container terminal handling. And this shows the strength of the digital standard. In fact, it shows the flexibility to be adapted to totally different types of equipment and processes. So thank you, Samsa and Danny, again for this explanation. And then let's quickly move to the last case of this first session of the conference. We are going to present a slightly different example in which third parties have implemented again this TIC 4.0 digital standard, considering communication of terminal assets with the terminal operation system of the facility, in this case, Thessaloniki container terminal in Greece. And for this session, I would like to introduce Ida Lundmark, Business Line Director at TBA, and also Frida Schutt, excuse my spelling, sorry. And Andrea Reis, don't know if she will also join. Yes, okay. And
we only see a white screen. Oh, there you are, Andrea.
And Saba Boer. Andrea is Senior Software Developer at TBA, and Saba is Chief Product Owner as well. So thanks for joining us today. And again, the floor is yours.
Thank you very much, Jose. So as part of Konecranes, TBA has joined this pilot together with Thessaloniki. And we use this 4.0 standard to develop dashboards with our digitalization platform. And we focus on the data from the TOS and the key cranes. And in this pilot, we will show you then a small movie about this pilot coming up, which Chaba will explain a bit more. So I will share my screen for that.
Remember to share the sound.
Yes, I share the sound. Let's see if it will work fine. Do you hear it properly?
Didn't see or hear anything.
Do you hear properly?
No, you didn't share, I think,
No.
Ida.
It's not sharing. Let's start again. Now?
Yeah. Yes.
Nice.
Our main goal at TBA is to simplify operations of container and bark terminals and warehouses. In order to achieve that, we create world-class software that supports from design, implementation to optimization. Our main container terminal products are the terminal operating system called AutoStore, automated equipment control system called Teams, and for emulation studies, we use controls. Using these products, in the last years, in a large number of projects, we learned how important is the data. These products produces a large number of equipment and operational data that we use to perform detailed analysis and to provide insight into the operation, both in real time and post-mortem analysis. One of our recent products is digital platform that aims to collect data from different sources, terminal operating system, equipment control system, and PLCs of equipment, and through data fusion creates extra insight, let's call it data value, for different stakeholders such as control room staff, continuous improvement team, customers. The data value chain that starts from collection to analysis and usage cannot be realized without proper data management. Our final goal is to optimize this data value chain by reducing the effort spent for data collection and analysis, and by increasing the usage of data value. In order to reduce the data management, there is a need for a digital platform that is based on standard messages, that aims for efficiency, robustness, reusability, and last but not least, cost effectiveness. In this iTerminal pilot project, we demonstrated the value of data by using digital platform that collects terminal operating system data from CTOS, CMHIT, and ABB IoT telemetry data from key cranes. The collected data is following a TIC 4.0 standard that has been agreed by multiple terminal operating systems and equipment vendors. Although it is worth to mention that neither CMHIT nor ABB were partners of iTerminal, but they still successfully succeed to adapt to TIC 4.0 and publish the data using this standard.
Morning, I am Francisco Lanquer, the Innovation and Development Senior Manager at Terminal Link, and we are going to install 4 IoT devices in 4 STS cranes and to do the deployment of big data platform and the integration with the TOS thanks to TBA. Let's go. Okay, just plugging and it's working.
In this pilot, we demonstrated that 1. Data collection and management from different vendors could be realized in a relatively short time when the standard is available. 2. Creates a value for the terminal by converting the TOS and IoT data to KPI charts that supports the operation, such as equipment utilization or equipment status distribution.
First impression, I love the two visualizations of the bottom. Very good, very good. Really good, eh? It's better than any one that I have made in the past. So it's really useful. In one view, you see a lot of things, and you can understand and identify problems in the data. My experience. You don't realize that one data is wrong until you see this type of graphs. So you say, hey, why we don't close this move? Why this happens? And it's impossible for a manager or something that takes care of the system to know if everything goes fine in the system without visualizing in this way. I had that experience everywhere, and the data quality is very bad in general in all the sectors, not one or the other, because it's very normal that some inconsistencies in the data. If you don't visualize that, it's impossible to fix the bug. Nobody realized that the job instruction is open.
In the future, we aim to continue using this standard in our projects, collecting data from different sources and apply data fusion in our digital platform. We strive to further generate values from the data by creating software tools or plugins on the top of digital platform that we will support the continuous improvement, optimization of the TOS, root cause analysis, bottleneck analysis, or even predictive maintenance. That's the future.
Will unmute myself. So I will stop sharing the screen. And so that was the introduction from Csaba about our achievements. So in this, during this iTerminals project, what we found out was what this common language of TIC 4.0, it helped us really to very quickly align on exchange of information. So we managed to get it up and running maybe 2 to 3 times faster than we would have without this common language to deliver the first dashboards. So it was in a very effective and efficient way. And the collaboration was also very good together with Thessaloniki, Pro Development, Terminal Link, and also with the non-iTerminals contributors, as China Merchants, TOS, and ABB. There were also good collaboration there. So I was very happy with the fast pace in this to create the first dashboards. And what we would like to highlight is a bit the approach we took here. So that's first we were aligning with Thessaloniki to see what are your most important KPIs and what would you like to get out of this. And we agreed upon, so they would like to see maximize the utilization of the equipment and also minimize the unproductive moves. So we were focusing on those parts. And after we identified what the Thessaloniki wants, our customer, we talked to China Merchant IT to identify together what data we need from CTOS to make the KPIs. And after that, we, together with ProDevelop and also China Merchants IT and Terminal Link, extracted the data from CTOS, got it into Kafka, where we publish it, which is a data processing platform. We used it 4.0 tick format here. So we have it in this Kafka form in the processing platform, and then after that, we could add this to our digitalization platform, which mentioned in the movie, and there we could process it and create the dashboards. So to really get the output of the KPIs shown in the movie. And looking back at this whole process, what we learned was, first of all, it's very important to align what does the customer really want. So talk to that we talk to Thessaloniki, what do they really need? So that we first did. And also start early to create the content. So actually, in our case, then the dashboards. So only when you really start making the KPIs, you see, oh, we're actually lacking some data. You see something is not available in one system. You need to maybe look at options to go to another system to get the data. Or can we even fuse them? So yeah, that's an essential part of the digitalization platform. And what we saw, extracting those data can be very time consuming and challenging, especially when you have several different systems. And with this standard, it really helped us to implement it in a common way, and also how we communicate about the data. So it's stored in a standard way, and is also reliable and coherent, transparent. So all in all, a very a successful pilot for this part. We all agreed that it benefited a lot, this TIC 4.0 standard, and we're also looking forward to look further with Thessaloniki or deliver to other terminals this proof of concept that we set up. And now I would like to show a small demo that was recorded earlier today by Frida. So I will share my screen again. Or Frida, do you want to say a few words? I think I go directly to the demo, right?
No, you can do the demo, yeah.
Yeah.
Good afternoon. I'm Frida Sut, and I'm working for over 20 years at TBA. I'll give you a short demo of the dashboard that we created for Thessaloniki. As was told in the movie, we received TOS messages translated to tick job instruction messages containing all available information, like type of job, but also for each of the steps in the job, the start and the end time. This tick format made it relatively easy for us to process the information. Based on this data, we created a SC dashboard with the data visualization tool Kibana. This dashboard shows several types of information on the SCs. The first graph shows per equipment the status. As you can see, we divided the statuses in driving empty, driving laden, and idle. I must note here that we are still waiting on some extra information, so as currently we cannot see the difference when an equipment is idle or when it's really offline and is not working. So currently there's too much idle time. The first graph shows the information per SC, the other graph shows it per timestamp, and then it's the sum over all the equipment. The bottom two graphs show the information a bit differently. They show it over time. So here you have the time axis and the bars are shown per equipment. The bars show here what type of job it's doing. So for example, if we take SC16, you can see that the first hour it was not working. Then it started on a receival job, started working on an inspection job, then a bit longer on a delivery job, and so on. So you can really track what each equipment is doing over time. The last graph also shows it over time, but then it shows the status. So you can see when it's idle, and then you have the regular sequence driving empty, driving laden, driving empty, driving laden, and so on. So you can the value of these last two graphs that you can really zoom in on specific moments in time and you can find out what was happening. For example, if you see that the equipment is in a status for a long time, there could be a problem with the data, but also it could be that the equipment was delayed on the terminal. Also, when you see that the equipment is idle for some time, you could also zoom in the data to see if it's correct. And maybe the equipment was just waiting for a long time. As next steps for us are also creating a key crane dashboard by combining the data from the TOS and the data from the actual key crane. That was the demo. If you can have any questions, you can reach us this way. Thank you.
Yeah, thank you, Frida. So, thank you very much. So that was our demo of this of our pilot with Thessaloniki.
Thank you, Ida, and the rest of the TBA team for this interesting demo. And well, I would highlight some important aspects that you cover in this pilot. Is not only the importance of gathering data, but also the importance of providing a useful visualization framework for this data. We are all of us in the industry are talking about how to use how to extract value from data, how to use data, and in the end, in practical terms, you need to use or you need to have tools that help you to identify the gaps that you have in your process, and support you on taking decisions to solve that. So I think that with your demo, you showed very clearly that we need also this type of tools to manage high volumes of data, which are not manageable by, let's say, human knowledge. And we need also support from IT visualization like this. So thanks again. Not sure if you would like to add anything else, or is
just confirming that indeed what we're going for, that it should be easily processable data for a person, that you really see, oh, here's something wrong, and that to be able to take action on it.
Perfect.
Csaba, did you have something, or Frida, or maybe? Yeah. Thank you.
So great. Thank you, all of you. We have showed you to all the audience different types of application in this first block of the conference. And well, now we have arrived to the second session. We would like to have a little more interactive space. And that's why we design, or we propose a roundtable with some of the iTerminals 4.0 participants to discuss and to exchange their views in this learning process that have taken us around 3.5 years of the iTerminals 4.0 project. So I would like to kindly invite the roundtable members. Francisco Blanquer, you already know him because he's appearing constantly in the videos. Heiko Wolf, who is group leader automation on drives and control at Kone Cranes. Good evening, Heiko. Patrick Snelders, who is enterprise architect at PSA Antwerp Container Terminal. Hello, Patrick. Thanks for being with us. Pekka Ili Paunu, Research Director at Kalmar. Hello, Pekka. Fritz Algira, who is Global Program Manager at Heister Jail. Hello, Fritz. And Norbert Klebner. I know you are traveling, but you are here with us. Thank you. Hello, Norbert. He's Managing Director of the EMEA office of RBS. And finally, Dimitris Sitsamis, who is Senior Innovation Manager in Terminal Link Thessaloniki Container Terminal. So welcome all of you. And this is a mix of port operators, let's say process experts, end users, and technology providers. So one of the values of this project is that we gather together these different profiles working under the same objective of boosting standardization. And I would like to maybe launch a first question to all of you, but feel free to ask to both terminal operators and equipment technology providers about what is your perception about the value that standardization creates in the sector, in your business, in your daily work. Which are the benefits that you are experiencing or that you foresee that standards will bring you? Who wants to break the ice?
Well, let me break the ice so that I'm rid of that one. PSA was already working for a longer time with our vendors to gather data from out of the equipments. The result of that it was always a limited set of data that came out, and then aligning the vendors with the different versions of their stellar carriers and whatever was always a pain then for the applications that came behind, because they changed, new versions, new information, etc. And with that, with the help of Francisco, we were able now to get there a version out that is now commonly used. So everything behind catching that information now becomes more simple and more streamlined compared to before. And before we had the difficulty always to align the versions of those elements. So this makes our life now great, so that we don't have to catch manually counters anymore, can get them out and put them then in that platform that can then in real life be used directly now, instead of a lot of pre-processing or after processing before it actually can really be used. That is our biggest benefit at this moment in time.
Okay,
thank
perfect.
You. Patrick, you are absolutely right. You know, the origin of everything was that doing big data in Valencia 7 years ago, I said, this is a nightmare to get the data from the equipment. And when I have to copy and paste the Valencia Big Data project in Malta, it's just impossible. It takes 2 months of an expert to get the data from one family. And in Malta, we have 10 families. So only 1 year to address the signals. That was the origin of everything. But on top of that, we say, okay, now we have the data, we get more value than that. The immediate one is to get the information. It's just plug and play, completely different. And the second one, it was the language. Once you have the data in place and you start to publish everything, the first question you receive from Heinz Security is, what is the meaning of that number? And when you have, as my case, 600 numbers in the digital twin, and say, I have to explain you the 600. Well, we need a language. And that is the second most important value is, are we able to understand the data? Before combine data, you need to understand individual data before combine. And for that, you need a way to describe the data in the name itself and a definition. As we say, we can ask now Dimitris. But that is to me the second most important value. Data understandable by people. Then next level is combined data. We are scaling in the complexity of how we manage data. But yes, first is to get the data. Second, much cheaper than do it yourself. Second is the understanding the data. Third, once you have the data and you understand the data, okay, you can copy and paste. So this is something very stupid, but in my case, I want to copy and paste my digital platform in all my terminals. And if we don't have a standard, I cannot copy paste. I have to start from scratch every single terminal. If I can copy and paste, it's much cheaper. And a good example is Thessaloniki.
Yes, that's what I want to stress, that in our case, a copy and paste of the software that was already made with minimal changes enabled us to have this data and achieve the target much faster and much cheaper than in Malta, let's say. That was the first pilot. So yes, standardization, it's enabler in technology, enabler in big data.
I think also all the different examples have shown that the key is that the standardization enables different parties that are usually like competitors and to still work on the same information. And for the past 20 years, it was always the question like, hey, can you integrate with this? Do you have a standard? And the answer was always, yes, but it's my standard. And that basically means it's not a standard. It's just mine. And now basically the answer would be yes. I mean, we can talk TIC, so you can integrate and you can understand the data. What Kuro has said, like you read it and you know what the value 601 means when Kuro gonna add it to Malta. And, I think that's the key value, the understanding of data. It's not so much on the technology, whether you now exchange XML or JSON or flat file. That's not the point. It's making this data understandable.
But we'll also say from, sorry.
Oh, so, but, yeah, let's say from a component or equipment supplier, I think also this TIC format is for standardization, which means more efficiency. But I think also based on that, everybody talks TIC. So the container handler talks TIC, the operations talk TIC, and also the mainstream talks TIC, but also the secondary processes like preventive maintenance, which can be included in the whole process, which means that not only operations is let's say the main driver, but also the equipment health is a key part in that. And I think that's very positive also to keep the equipment longer running and also more healthy running on the site, which actually helps also the safety and the sustainability of all the components on the site. So everybody talks TIC, which also means that all the equipment on the site is healthy.
Fitz is talking about health. Health is maintenance. For the people that doesn't talk TIC, health is how is the healthy the maintenance of the machine.
That's correct.
And also, let's say it's on the other side, also good for us because, and then we don't have the request. Every terminal has its own interface. It's this, is this, is this. That's gone, You can have a TIC interface with this variables, with this information. Yes, that's available. That's what you can have. But you can't have 5 more, 5 less, this in this way and that way, because otherwise it's not a standard and you start again and again from project, because also we want to copy. If we copy, it's okay from the price. If we do all developments every time, then it's not a standard. So you have to, and of course we have to manage it. Not everybody wants to have all, not everybody wants to have a digital twin. We can start simple, twist lock locked, unlock landed, PDS information, and you can go up to, a digital twin, which is maybe for Malta, maybe for big ports, but not for a port which has 5 straddle carriers, it's over the top.
But again, if it's copied, then also it's easy also to do for the smaller terminals to have something included in that.
Yeah, but also remember, data and software has a value.
Yeah, that's for sure.
That's something for the sales guys.
but it does lower the barrier of entering this kind of knowledge of data.
Yes,
and
exactly.
I think looking back on the journey with TIC, that is certainly one thing. On both sides, it lowers the barrier on the supplier and solution provider side, but also on the terminal side to do plug and play. Basically, that's the example between Malta and Thessaloniki, where Malta being the flagship terminal, I guess, and pushing forward and having maybe the resources, and then you share that in the group.
Yeah, I can add also that we have been supporting open data quite many years already, but we have had our own APIs, and of course that's one way to do it. But now we have this TIC standard, and that makes it really easy to share data. But of course we have our own role in this chain, that what kind of data we can provide and what we are doing on board the system. Of course we are not always sharing the raw data to our customers, and we can really calculate many things, as Fritz already said, that how to really implement this predictive maintenance part. That of course the onboard system has a really important part in that one.
I think that is very important when you talk TIC. It doesn't mean that inside your system or inside your equipment you need to talk. You can still do whatever you need to do in your own architecture, in your own part. But if it leaves your premises, so to say, and it goes outside, then you should talk TIC. Whatever you do inside is your own knowledge, is your own property, is whatever you need. And to the outside, you talk TIC, and probably in the future you're gonna listen TIC as well.
Exactly. We have more flexibility because we have this standard available.
TIC is the firewall to the outside world, so you don't have to ask again, what is your information here, what is your information there. So it's a two-way advantage. You get the fuel level, everything in the same way. You don't have to compute it, whatever. That's it.
So listening to your conversation, what I extract is that the application of standards, on the one hand, there is a clear reduction of cost of implementation, and secondly, the speed of doing this implementation accelerates very much. Kuro mentioned our first try some years ago. It took more than a couple of years to arrive to something, and then now we are talking about some weeks maybe. So this is
Valencia was 2 years. Malta was first version of TIC. In fact, was version 0. Took 1 year to do the deployment, and Thessaloniki 1 month. That is the reality. And now in Malta we are copy and paste. Malta is not a problem, but we are talking that you can implement telemetry and the digital platform and everything in a small terminal, not very complex, 1 month. In a big terminal, 2-3 months. Nothing to do with the 2 years, 1 year, lot of time. It's really impressive.
So this is a great, I think, highlight of this audit confirms what we have been saying all this time. So now I would like to maybe ask you, given that the project is at the end of its execution, what lessons have you learned from your experience, from the pilots that you have developed in the project? Is there any lesson or knowledge that this project has helped to you to understand better how to apply this in your real business?
It's kind of more, the implementation actually was not very, everyone actually involved in the project knows that. I have a huge security environment behind my back.
Yeah.
And where to start and where to end, and who can make connections to what. Like Heiko said, data has value. Yeah. So if from the moment you start to throw things just in the cloud, that was not allowed on our promise. You know that all as well. So there was a little bit of pain also, who can make connections to what devices and so on. And that is still perhaps something in general in the industry, where, because you have the Internet of Things and throwing it to the cloud as one idea. But that is something I doubt that my company will subscribe to. They will never do that. So we also have to think a little bit further on. Yeah, it's possible, of course, but yeah, supporting very well also to have it in the private environment to collect all that data. I think that was one of the lessons during our exercise, that we should look into that as well, and how to set it up on those machines, so that it is not just throwing some information just around, but keeping that in the right tunnels, let us say, to the right parties. That was important for us.
Our lessons is we didn't have so much problem with security. We have it, but not like PSA. It was terrible your case.
Realistic perhaps. Did you read the newspapers? Antwerp town was hacked. Complete Antwerp.
So why so much security if at the end nothing works? No, but it's true. In my case, my security people asked me to put a firewall in every single IoT, that the firewall costs like 20 times more than the IoT and all the installation. I say, sorry, I think you don't understand. We are here in a very local environment, and you want to put here like a protection for, I don't know, for the corporate headquarters. It doesn't make sense. But finally, all the partners get the approval of security in CMA, and with external and internal, no problem. Was quite easy, quite straightforward. Even in the cloud solution, that they were certificate. Kalmar, ProDevelo were certificate in CMA to have data in the cloud and to connect from the cloud. But to me, the most important lesson learned was the data quality. I really underestimate the data quality. What I mean, once we get the data and we can understand and analyze the data, my finding was that the data quality was a disaster. So lot of sensors were wrong, lot of data from the TOS were wrong, and nobody realized that that was wrong until we made the analysis. So you think everything is running fine? Your IT network is running fine. Your anemometer, your hoist meter, your power meter. You think everything runs fine? And absolutely no. The problem is nobody have looked at that data ever. And we discovered that in the moment that you monitorize, you really monitorize what you are doing, you discover that the reality was wrong, so you have a real problem and nobody realized, or the data was wrong. So, and that was wrong since ever. And when you apply that data, I'm not talking about Malta. We have 4 pilots, and in the 4, the same findings. So when the data is wrong, the automatic decisions are also wrong. So if you have a super nice TOS that is taking a nice algorithm to order the containers in the yard or to pull in the terminal tractors to the crane, and the data is wrong, the algorithm will give you shit. You put in shit in the algorithm, the output is shit. Without this visualization of data, without this digging into the data, you cannot realize that things doesn't work properly. It's impossible. So that was very, very hard finding. So when you open the box, the Pandora box, you have a lot of shit inside, but also very good because we could clean the box and improve a lot of things. So let's see, how do you manage that? When you open the data and you discover that the content is not very nice. That is a social problem with the workers, social problem with the management, social problem with everybody. And the way to visualize the data, once you discover that a machine is idling 50, 60, 70% of the time, but you think you are doing a fantastic job, but 70% of the time idling, this machine is not doing a fantastic job. And then you have that conflict between all the people. No, I'm doing my job super well. I'm super professional in operations. How can you tell me I'm not doing a good job? I'm only telling you the data. So be aware. It's going to be really difficult to increase the data quality, and it's going to be a challenge to move the people with data. So to convince the people that the data is okay, and the reality through the data is very different from the reality that you see through the window. And that was, I underestimate that because I'm used to data. But when you show the data to everybody and to the new people, they are not ready. They need time. They really need time.
Yeah, really good points, Francisco. And because we have utilized data for a while, but we realized, of course, the same thing, that data quality first, you have to fix it. And but when you have a good quality data, you can have also surprises how the operation is really working. And we have found so many surprises, and even our customers didn't understand that why this is possible, how it is happening in a manual terminal. But that is really relevant point, that the data quality is really key in this kind of processes. And now we have a possibility to really provide good quality data for everybody, and we can share and we can build information and knowledge on top of that one. And of course, I want to highlight that we have been spending quite many hours and days discussing about KPIs and how you calculate the KPIs. And now this is giving a really good basis for that one. And also I can highlight that this is really good basis for automation, on how you can build on top of these ideas automation. That makes also automation part a bit easier.
Yeah, and I think also next to that is all the time we spent on creating the definitions, so that all the insights the different persons have. So also between the equipment suppliers, but also the customers themselves. So everybody has his own idea about the definition, and I thought we had very good discussions about, okay, how can we create a definition which is understood by everybody but also agreed by everybody. And I think, yeah, we still are processing that, and I think also based on that, every time new definitions come out, and also I think more data will be at least good understood with those definitions. That at least we have an efficiency that everybody understands. Okay, this is idle, or this is what I learned from Kuro, rallenti and non-rallenti and all those kind of things. So that was,
what is a move? What is on?
What's the move?
What is on?
Yeah.
What is a standby?
Yeah. So, but I think now by all these definitions set up, it's now clear for everybody. So it's well described, and based on that, I think it was a good learning lesson, at least for me, but I think also for all of us to have a good understanding what was where we have been going through. And I think now we have a very good foundation for creating more definitions and also do the further steps in that.
And I say that the needs are, or at least what I see, is totally different. As you say, on, off, idling, what else? The others are purely interested in tire pressure value, temperatures, fuel levels, oil levels, and yeah, they want to check the machines. They can do better maintenance, whatever, That's why I say there will be different methods or different approaches at the end to say if it is simple, medium, or high end, Yeah, but as I said, that's just a test. You have just one prototype, and the next step is then, of course, where we come later on, how to make sure that really it's working in a bigger scale without changing then again from daily software and updating and keeping it up to date for bigger fleets.
I think, also one point now, as Kuro said, or we all said, okay, you can now understand the same data and everybody sees the same data, and yes, you need to fix some sensors and you need to increase data quality, which can be done. But when you implement all things, what you have to bear in mind is that transparency is not everybody's friend. And I think that can be, to my experience, that's one of the biggest. I mean, we are 2022, so technology is usually there. Yes, it needs to be standardized and all those things we're working on. But one of the main points when you implement such a, you make bluntly transparent what is happening, and in your organization, I think you need to be aware of that, and you need to make the organization aware of that. So change management, not only in changing sensors and changing the language, also in kind of way of working and seeing the data and understanding it.
Okay, I think you are touching really key topics like data security, data quality, transparency. I think each of these topics could have could take hours of discussion. So I really would like to have more time to keep diving in this. But time flies when when we discuss about these topics, and now I think we need to move to the next and to the final part of the conference. So I just would like to thank you for your reflections and interaction in this I'm sorry little time, but I would like to ask the audience to give an applause, to a virtual applause to our speakers in this round table. Thank you very much.
Welcome.
And then well, it's almost 5:10. We had a program a little break, but I'm not sure if we are feeling like continuing the conference. We have three more presentations ahead. Really interesting, focused on maintenance, energy, and safety. So unless you are against that, I propose to continue. And then, okay, Norbert, you agree? So
it is better to continue. There is a question in the chat. I think it's for me.
Yeah, there was a question, yes, related to the digital twin.
Malta is running since when Malta was we started 4 years ago. The first set of 15 RTGs were running at the end of the year, so 3 years ago, with 6 STS, and then we connect the track, yes, also at the end of that period. So in Malta, the 15 RTGs and 8 STS plus the 240 tracks were running since 3 years ago, and then COVID, you know what was COVID? It was a nightmare to do anything, to install. We interrupt the installation of IoTs. We went really slow, and like 1 year ago, we finished with everything, and all the equipment is connected and running. The toast took a little bit more time because Navis came on board to take later. Navis is not a partner of the project. It was not easy to connect. But we connect Navis. We made a pre-connection at the beginning 3 years ago, and now we have a better connection. And Navis is going to adopt in the enterprise bus data TIC. I hope it will be ready in 2 years. So that is for how long we have been running this.
Okay, thank you for answering the question, Francisco. And then, so let's move to the final part of the conference. So thank you again, all of you. And then I would like to welcome our next speaker, who is Jan Willem Houwers. He is Senior System Engineer, Product Digitalization and Automation at Heister Yale. And hi, Jan Willem. And Jan Willem, is going to present two pilots that have been developed within the framework of the project, focused on using, again, harmonized data to improve or to advance towards a more advanced predictive maintenance, and focused on tire management and oil equipment monitoring. So, Jan Willem, you have the word now.
Yeah, well, let me share my screen. I hope that everybody can see it correctly. So this is about the application of the equipment maintenance, and I have to do something about the lighting because we're getting dark. Sorry for the noise. So give me a second. So basically, we have a few topics. And so my name is Jan Willem Houwers from HTL. We have some pilot presentation. We had two topics on the operational maintenance, one for the smart tires and one for the smart oil, and a setup for TIC 4.0 for mobile equipment architecture, which is in some aspect also quite a bit differently than your typical STS or RTG with maybe PLC-like of architecture. So we have demonstrated at CMA CGM Malta Freeport, and we did that on 2 reach stackers and 2 empty container handlers. And those were already existing trucks there, so they were not new trucks from us. So in the end, we give you also some impressions of, we think we're doing digital, and doing digital and going digital initially turns out in a very big plan of all kinds of, in this case, retrofits, because we had to add a lot of sensing hardware, even install new wheels, for example, because we did it on existing machines. So normally would kind of say in Malta, it can be pretty nice and warm. And sometimes you're in the water. That is also part of the game. And it ended up sometimes in some night work. So we were very happy with all the support from the Freeport people to kind of help us and work together with them, like with Daniel and with Kuro, also like Brian Gaffa of the maintenance department, many of the mechanics, to all in the end install it all, because I think in the end it was like 500-600 hours of work. So I'll do a small demo with a small video, and after that we will take the topics.
The iTerminals 4.0 project is an initiative co-funded by the European Commission through the Connecting Europe Facility Program. Its objectives are to advance towards the standardization of processes and the application of Industry 4.0 technologies in port container terminals. Maintenance is a key business area of port container terminals, which are highly dependent on equipment availability. Digitalization can provide significant benefits for the improvement of the preventive and predictive maintenance. It can extend the operational lifetime of port equipment and machinery and reduce maintenance costs. Thanks to TIC 4.0 and IoT technologies, different sensors, parts, or failure codes can be continuously monitored, helping to replace wearing parts before they are degraded and prevent unscheduled downtime. Digitalization of maintenance processes will help increase port equipment reliability and equipment lifetime, as well as reduce general maintenance costs. 2 maintenance pilots have been performed in iTerminals 4.0 project: Smart Tire and Predictive Oil Maintenance. When running a vehicle, the maintenance of truck tires is one of the highest costs in operations. Their proper maintenance not only extends tires' life, but also ensures operational safety in the terminal. The tire pressure monitoring system allows the real-time monitoring of key indicators to know the tire's status in real time, thus allowing to perform any kind of preventive and predictive maintenance at the right moment. Trucks' oil maintenance can also be costly, depending on the time replacement. The real-time oil monitoring supports maintenance when required. This action will prevent extra wear and potential drastic reduction in components and truck system lifetime. iTerminals 4.0 has developed a new approach to improve operational maintenance through standard digital exchange of data, which will allow port operators to detect and manage in advance equipment incidences, thus improving the overall efficiency of port terminals and also enhancing equipment performance and their lifetime.
So now we will continue a bit on the different topics. So about smart tire, we partnered here basically with Malta Freeport, but also with some of our strategic suppliers like Continental. In the end, to kind of say, trying to change to a preventive maintenance process by using really data-based approach to in the end go from overview into insights. And in the end, it starts with getting the right data, getting it from the right sensor to be able to present it in the right insights. In the end, to be able to say, hey, can we monitor it real time and can we process it for insights? And then mainly that last part, I think, is pretty important. So if you talk about maintaining tires or keeping them properly pressurized, you can kind of say the typical challenge is you're controlling something secondary. It's like the same like your car. You don't buy it to pump tires. It's the same like our truck. You don't buy it to pump the tires. You buy it to move the cargo payload. But hey, doing it with a flat tire is not really working. So there is some boundary you need to get in place. So typically you see when not doing it with data, you typically come from preventing underinflated tires because they're forgotten or address tire leaks, which are typically outliers. You do some scheduled check and pump. But as you don't really do it based on data, sometimes it's not that efficient. So if you look overall, in the end, what you're trying to do is using the technology, using the information to optimize the target and the range. So in the previous slide, we can kind of say, hey, there is some basic information from like tire manufacturers to say, hey, if you run it at the correct pressure, 100%, you're going to reach the optimal tire life. If you're under pressured, you basically reduce a certain percentage of your lifetime. And that's a relatively costly part if you look at in a port how many tires are running around, but also from, say, a maintenance perspective, but also from efficiency and even sustainability, because you don't get the life that you could potentially get. So typically what we're trying to do here is you're coming from a process with more variation, not at the average target where you want to be. To in the end say, hey, how can we reduce the variance because we're detecting we're going too low much earlier and reacting upon it, and also in the way of, say, pumping more smartly with help of the data, pumping in the right way to actually achieve more precise pressure on target. So it's kind of reducing variance and moving the target. So we started on one of the trucks, for example, these are 6 tires on an empty container handler. So these are the 4 on the front axle, 2 on the rear axle. Malta Freeport installed them, put pressure on it. We had the TPMS system installed, get the data connected. And basically they installed and pumped somewhere in November 21 till like February 22. We kind of said, we're not going to affect the process of what they normally do. And you can see, hey, you have less optimal target, more variance. If you say, hey, there is one tire which is kind of okayish. Okay, it's maybe pumped even a bit too much. Here we had the one outlier which actually was leaking a bit. Therefore, it's going down much faster. And some others were initially a bit on the low side. Later, they were maybe a bit high. all in all, you kind of see there is more variance, and you're not always on the target pressure where you want to be, which is in our case 10 bars in the middle of the line. And then we started influencing the process. In this case, for example, we learned the people how to pump based on the temperature of the tire, pump more precise when pumping. You can imagine sometimes a mechanic which says in our case, hey, the job only starts from an Allen wrench bigger than size 36. If that guy needs to pump tires precise, maybe that can be challenging. But if you do it and you look over time, actually see they pumped it in September, and actually it's still running, and actually running quite optimal, very close to the target, with a lot less variation. So you can kind of say, hey, well, data can really help you to optimize it, and I think it's also very important with the people. Yeah, you have to take the people along. They need their time to learn, and you have to repeat a lot, but also train. So you have to organize it. So, but I think you can reach a good result there. So, and in the end, if you look about the smart tire, in the end, we have, say, the machine with the operator. On the other hand, for example, the operations also needs to know if something is wrong with the tire. The contractor that's maybe pumping the ones, they needs to know when to pump what. Try if you in Malta you have several thousands of tires running around, you want to pump the right one and not actually the one which is okay. So if something is wrong, you need to repair it. You have the maintenance department partly also monitoring it, doing some of the repairs as well. And in the end, as the management, you want to monitor, hey, are we running this secondary process in a very optimal way? Does it not lead to additional downtime? Can we optimize the cost? Can we increase the safety? So I think that's all what comes to this. So that is a bit for learning. If we say, hey, you can say it like this, if tire maintenance is done optimal, it really helps to improve the safety and efficiency and the sustainability. And with preventive tire maintenance, you can also say it the other way around. You actually spend less time on pumping and actually have less scheduled downtime. And I think really here the TIC data-based approach really helps you for overviewed insights, because in the end, there is more stakeholders than just the people that maybe pump the tire or the operator that's seeing some of the pressures. So you want to have everybody contribute and improve from an operator to a director. And that this is where I think really the TIC data model for maintenance and external service providers, I think we haven't focused so much as a TIC on that. We have focused initially, of course, a lot on getting the data from the equipment. Now we're seeing getting the data from the TOS, but I think also the data from maintenance department or even some external service provider, how to provide the external tire pump contractor with the right data. So that is all coming, and so that is for the tire. If you think about, we prevented a pilot for the smart oil, changing really from preventive oil maintenance process to, in the end, like a more based on the data. And in the end, it's like a sensor fusion of sampling oil and oil reports and electronic sensing. We call it basically real-time oil monitoring. And we have oil sampling that goes to a lab. So in the end, it's all about changing oil only when needed, avoiding running with oil that needs replacement. It's like you have oil that's still worth, say, maybe 50% of its life. You throw basically 50% away as an asset. And on some of our equipments, the amount of oil is quite a lot. And on the other hand, you want to flag, hey, I'm running equipment with some oil which I shouldn't run anymore because it's creating severe component damage. So we run it on 2 tracks. On an empty container handler, we run it on engine, transmission, hydraulics and brake. And on a reach stacker, we run it on the hydraulics and the brake. And there is quite a long time of doing this sampling and building a model part. And actually here we partnered with our long-term partner also, Shell in this case, because they're really the experts on oil. And in the end, we also rely on service tech information when they change oil. In the end, to do data correlation for insights. And it's like running a continuous learning environment initially for a long time. To in the end, after just over a year of running it, we have, for example, been able to stretch the oil drain interval of the engine by around 50%, in this case on an empty container handler. And that helps the port also a lot in reducing the amount of planned maintenances as well. And it gives some savior also on, you can calculate the saving in carbon or in amount of oil. So it has several benefits of doing it, while actually we also know if something is wrong. So I think that's the learning. If done optimal, yeah, it also helps on that end for safety, but also for the efficiency, but also for the sustainability. And with this oil maintenance, you can say, hey, we can see the condition before failure, potentially use less oil, but mainly less unscheduled operational downtime, less planned maintenance in some cases. And I think also here, database of TIC-based approach, I think it helps for the overview. You can allow everybody to get the right insights, so everybody can contribute. But also here, I think, especially in these cases where we might need some model for how does external sampling, how does this data outside the port from service providers come into the local environment of TIC, with like the discussed security on data. That I think are still some points where we have to evolve. Then we come to the TIC 4.0 mobile container handling equipment. We say mobile equipment architecture, talking TIC. We as Hyster, we typically have say automotive architecture with mainly CAN-bus communication, where also a lot of standardization is already ongoing for a long time. So in the end, it's all about talking the same language, making protocol translations more easily. In the end, also as a manufacturer, we have to ensure that from the IoT end or the data end, also we cannot affect the vehicle in the wrong way, because we have to still comply to the machine directives, and we want to ensure the safety of the equipment. So we set up an iTerminals architecture, I think 3.5 years ago, where we kind of work with like a truck with collecting the CAN data from a kind of router or logger in our case. We also have from that way a secure connection to our cloud, because we also need to do the learning. We need to see what we provide, for example, to the IoT device. So in case we're working together with ProDevelop and we're evolving and we're working on this, say, data quality issues, that we know, hey, this is what we have been sent. Hey, the outcome looks like this. Hey, it looks like you're converting something not correctly, or we have to filter something. And in that way, we were able to, say, talk TIC with also the mobile equipment. And I think this is an approach, on one hand, it's maybe not always the level where everybody wants to be, not publishing, but it also gives some flexibility of we're giving a CAN interface in a standardized way, which is already has links to kind of direct TIC signals. And it also can give you some flexibility on the IoT edge. If you're working with a dedicated partner that does this, that can also give you an advantage. So I think if you look at the learning, typically, yeah, we can say, hey, from CAN-bus to TIC, that can be quite well, and we can actually do a lot of one-to-one translations. And also more processed TIC 4.0 is pretty well possible, even really one-to-one. And allowing edge flexibility. And I think also the other way, I think the other one is the domain-specific learning. Sometimes that is also required. Like examples on periodic maintenance, you need to have some background in that typically to maybe understand the data. And I think we'll evolve in time to basically get maybe TIC 4.0 domain specialists in all kinds of areas. And I think this is where the standardization of the language really helps us. So, yeah, iTerminals, what did it empower? I think we demonstrated pretty nicely the proof of concept. It works quite well, making improvements possible, but standardized, sharing data at different levels, and very important, assisting humans to learn and improve. And I think that in generally is one of the most difficult things with going more digital, really taking the people along, really from start to end. That is typically what you need to do on the preventive maintenance. And I think Che enabled data sharing at different levels within terminals. I think also enables secondary processes like maintenance. And I think the TIC domain specific learning started. We really have to aid the people in the process. And yeah, as a reference, I think you can also still look at some of the articles that have been published with help of ProDevelop, Terminal Link, and Heister. So yeah, I would say thank you for your attention.
Thanks a lot, Jan Willem. Really nice presentation, and as you can see, another angle of the application of standards or digital standards. Fritz, you raise your hand. Do you want to say something?
I was giving applause to Jan Willem.
Okay, yes, yeah, big applause. And yeah, I was just pointing that during the whole meeting we have been talking about the importance of applying digital standards to improve operations, but now we are entering into other types of applications that you are seeing, like a maintenance and the tremendous potential that we can also have in that area and in other areas that you are going to see, in like energy or operational safety. So again, thank you very much, Jan Willem. Please stay with us just in case there is a question from the audience at the end. And yeah, congratulations for this presentation.
Yeah, well, thanks. I think it wasn't been possible if we would not have had this great cooperation. I think in the iTerminals project. I think that's that's a really good takeaway with the different levels, different stakeholders, and yeah, looking forward to many TIC continuations. I think.
Yeah,
so
we
thank
hope
you.
so. We hope so as well. Okay, so our next speaker is Ignacio Benítez, is Energy Transition Innovation Manager at Fundación Valencia Port, a colleague of mine. And Ignacio is going to present what we think is a very relevant approach, not only for the port industry, but for all ourselves, is the focus on energy. And we found also a great potential application of digital standards in the way we can calculate what we call the dynamic carbon footprint of container handling. This is an exercise that has not been developed, at least as we know so far. But with standards like the TIC language, we could be able to quantify in real time the emissions that are generated at a terminal by moving every single container. So we could quantify a unique value of carbon footprint for each single container moved at a terminal. But for this, of course, Ignacio is going to give to you much more details. So please, Ignacio, when you are ready.
Hello. Thank you very much, Jose. Well, yes, as Jose said, this has been an activity being done in the context of the iTerminals project. And the objective of this activity, it served as a proof of concept of the added value that we can build upon an implementation of TIC 4.0, TIC 4.0 language at a terminal. As an introduction, I have a brief video describing this proof of concept, and I will show the video. I will play the video first, and later I will explain you how we defined this pilot and we performed it at Malta Freeport. So let me share the video first. Okay, hope you can see it.
The iTerminals 4.0 project is an initiative co-funded by the European Commission through the Connecting Europe Facility Program. Its objectives are to advance towards the standardization of processes and the application of Industry 4.0 technologies in port container terminals. Decarbonization of operations through advanced digital management. Have you ever wondered how much energy is used to move a specific container at the yard? What is the impact in emissions of container handling logistics at port container terminals? Digitalization plays an important role in the capacity of ports to reduce the environmental impact of container handling operations. The iTerminals 4.0 project has developed and tested innovative solutions that support decision-making based on real-time data acquisition and the continuous monitoring of the energy consumption of port equipment. The iTerminals 4.0 approach allows to trace the internal movements of containers and to calculate an individual carbon footprint signature for each container operated at the terminal. This methodology also enables the assignment of eco-labels to containers depending on their carbon footprint signature. The strength of this solution relies on the ability to aggregate big amounts of data and calculate the emissions generated in the operative of a specific vessel, maritime service, or even the entire port terminal. Moreover, it is possible to monitor the performance of the terminal's equipment and define individual indicators to measure the environmental efficiency of the terminal's assets. iTerminals 4.0 has demonstrated how digitalization of information can generate a measurable impact on the environmental performance of port container terminals. This achievement will allow port operators to easily include the environmental perspective on the operational framework of cargo handling logistics at ports.
Okay, let me go back to the slides. Now, if you can see the slides again, and now this was the presentation of this activity, this proof of concept. Now I will tell you how we could make it. Let me summarize first. What was the objective? The objective was to prove that we can monitor and visualize a carbon footprint and energy efficiency signature of every container that is moved through the yard. We are able, as you can see in this image, to obtain a measure of the energy that was used by each machine that moved each container through the yard, the associated cost of that energy that was used, and an associated carbon footprint of all that aggregated energy, taking into account the different energy sources used. If we have that information, we can go a step further, and we were able to define energy efficiency labels according to these values. And these values are dynamic. Why? Because they vary through time, because the data that they are based on also vary through time. We have them monitored in real time thanks to our big data platform that is based on TIC language, TIC language. So the granularity can be directly decided as a function of the availability of the data in real time in the big data platform. It can be each half an hour, each hour, per day, per week, any granularity that can be needed. Well, how we made it? We made it because we talk TIC. If you have TIC, if you have TIC language implemented in your terminal, you are almost there. You have, I would say, more or less around 90% of the work done. Why? Because it doesn't matter whether it is an STS, an RTG, a reach stacker, a terminal tractor. All these machines, from the perspective of TIC language or TIC 4.0 data model, are represented using the same data model unit, the same container handling equipment, CHE, data model unit. So they share the same semantics and the same format. What do we need? The basic information that we needed to perform this proof of concept, this pilot. We need energy. The energy being used by each machine to move each cargo or container. Do we have this information? Yes, we have this information because it is already there. If you have implemented TIC 4.0 language, you have that information of how much energy was used by each machine in each cycle. TIC 4.0 implementation provides you this data. The format is the same. The units could be different. If you have electricity, you have kilowatt hours in energy. If you have fuel consumption, you may have the information in liters or in kilograms. In this case, you will need to implement or to code some conversion formulas in your middleware layer or in your big data platform. But the information is there. What else could we implement here? We could calculate in real time the cost of that energy. For this, you need to code how much you paid for the energy you used. If we are talking about electricity, you will need to program to code the electricity tariff at your terminal. It may vary as a function of different concepts. You may have different time of use rates, for instance, that vary as a function of the hour of the day. You may have different charges varying as a function of the amount of energy that you have already consumed. You may have different charges varying as a function of the power contracted and other charges like interruptibility tariffs, for instance. If we are talking about fuel consumed, well, in this case, it might be simpler. You just need to program a parameter of the cost of the diesel used, for instance, per liter or per equivalent kilowatt hour. Having the energy consumed and having the cost, we also thought how we compute the carbon footprint. If we are talking about electricity and if you are using electricity from the grid, it gets a bit more complicated because you need to know about the production mix that was used, that is coming from the electricity grid. And this may vary depending on where you are and when you use that energy, at what moment of the day. As I said, this information is a bit more complicated, but it is still available. What we did is we took the information from the transmission system of operators of each country. This information is available. It is published by each national TSO in Europe. For instance, you can see there the information from 3 countries, Spain, France, and Malta. Spain publishes through an API a daily average of the production mix. France gives also this information each 15 minutes. And in the case of Malta, Malta gives or publishes a fixed value that is computed on an annual basis. And this is the value we used at Malta Freeport. Regarding fuel, or diesel, or gasoline, or gasoil, you have to take into account what are called the indirect and direct emissions, the well-to-tank and tank-to-wheel emissions. And you should code, or you should include in your code basic conversion formulas that take into account emission factors for the diesel. There is bibliography and literature available for this. So it's not so complicated. As I said, we have collected all this information. The basic information was already there, the energy consumed by each machine. We wanted to identify in real time an indicator for each container or TEU. So we wondered, is this information, can we extract this information? And the answer again is yes, because TIC language, TIC 4.0 language, allows you to discriminate the energy used for each machine, each cycle, and each cargo that was moved. Each cargo has its own unique identifier. So we were able to obtain this information, this signature of the carbon footprint and energy efficiency for each TEU or each container or cargo moved. And having this information per cargo, we can obtain a similar signature for each machine at the terminal. So in this way, having the information for cycle, for per move and per machine, we are able to define these energy efficiency levels for also the machines that are being used at the terminal. What can we do with all this information? Well, we defined some key performance indicators and some sort of visualization of the results. Each operator or terminal manager is, well, you are free to define your own KPIs. These are just an example of the ones that we defined within the context of the project. We have the carbon footprints per cargo or per TEU, then we can aggregate them in different levels. We can aggregate them and show KPIs at the whole terminal level based on a rate or an average, or per giving this information per TEU or per weighted ton or per order information if available, or we can define these indicators per vessel or even per service or other segmentation. And having all this information, we can visualize. We could visualize different indicators per machine. We could visualize a ranking of machines by time of use or energy consumed or their carbon footprint, and we could observe how these values evolve through time. We can observe the trends in terms of energy consumption and energy efficiency. Regarding the cargo or the containers, this is an example, but if you are a terminal operator or manager, you can segment the yard in storage areas, applying any criterion that you may like. You can segment by customer or services or function or whatever. And you can obtain indicators per these specific areas. You can compute and assign energy efficiency levels You can observe the average use of energy for each containers stored in that area, and you can observe the trend through time with the granularity that you may like, because the data is already being gathered and registered at your big data platform. So you can observe the trend by each hour or daily or weekly or wherever. And that's it. That was our proof of concept. We really proved that if you have the data, and we had the basic data regarding energy, then you can do this added value to visualize and to obtain these indicators regarding energy efficiency and carbon footprint. This is providing more analyzed information that later can be evaluated, and it might be useful to derive conclusions. The level of detail allows you to zoom into specific containers or areas or yards or services or vessels or any level of detail that you want. You can assign in real time or dynamically energy efficiency labels, and a further step will be from this information to build and derive your own forecast models regarding energy consumption and energy efficiency. And this is it. Thank you very much for your time.
Thank you. Thanks a lot, Ignacio. And well, I think that here it's important to remark the approach that we are giving to this important aspect of that will be, and it is now, but it will be much more important in the very near future. The way that port operations impact and which is the contribution in terms of greenhouse gas emissions. We have done, and many operators have done their studies, their calculations about carbon footprint. Of course, they publish, or you publish your value, your annual value of carbon footprint. But here we are talking about measuring in real time individual carbon footprint by container. And this shows the powerful or the power of this language and the potential application of this way of measuring through digital standards again. So, in our view, a really important aspect and a very promising approach to advancing towards making our sector much more transparent, much more cleaner as well, as we will have the ability to measure in reality how much energy, how much emissions are we producing by handling container cargo in terminals. Okay, Ignacio, thanks a lot. We are approaching to the end. Only one presentation left, and this will be developed or presented by our colleague Pekka from Kalmar. Pekka is research director at Kalmar, and we have talked about maintenance, we have talked about energy, we have talked a lot about operations, but there is one big pillar remaining, which is safety. So in order to address the operational safety issue, Pekka will present us a very innovative concept based on a concept called virtual geofencing. And again, this can be done through the application of digital standards and applying the TIC language to operational safety. So, Pekka, when you are ready, the floor is yours.
Okay, thank you, Jose. I will share my screen, just a second. Okay, I'm going to explain that what Jose already mentioned, that how we implemented the safety pilot and where we applying the virtual geofencing ideas, and I call this adaptive safety solution, and I'm going to explain that how come I can say that it is adaptive and what kind of adaptive features we have. And also we really tried to implement it to follow the Industry 4.0 standard interfaces and the principles what I mentioned in the 4.0 environments. And based on safety statistics, we picked up our use case to be a manual straddle carrier that is causing few accidents in a terminal still. Of course, it's a flexible machine doing many kinds of things inside the whole terminal area. You can, of course, operate under STS crane, or you can stack containers, and you can even load the road trucks if needed. And of course, we selected that kind of use case that where we have a mixture of equipment, vehicles, and pedestrians. And in the case of port, of course, then it is under STS crane when the manual straddle carrier is placing or picking containers. There can be our terminal operator employees working there, like releasing twist locks or checking containers and so on. So there is a case that pedestrians can be next to the container when the straddle carrier is approaching the area. And what we did is that we really built a virtual geofencing area under STS crane. And on the left-hand side, you can see the situation where the area is not occupied. You don't have any employees or persons walking there, or other vehicles like maintenance cars or so on. And so the operator, we are indicating with the green LED that everything is okay, and you can operate normally with the full speed. But on the right-hand side, you can see that where you have persons inside the area, we have detected those. I will explain how we did it, and then we are turning the geofence area active. So we are sending an alarm to the driver, and we are turning a LED lamp, in this case red. And we are also slowing down the straddle carrier before the virtual fence is broken, and we are going inside the area. So it is more safe, of course. In this case, you can see already that the driver, in this case, can't see the guy standing behind the container. It is not visible because the container is blocking the view. And what kind of components we utilized here. On top, you can see that I call it infrastructure, meaning here that what kind of components we installed to the STS crane. And on the bottom, you can see our straddle carrier components. On top of this picture, we have 2 cameras we installed on both sides of the STS crane, and we utilized this kind of intelligent camera, including all the software and everything inside the camera itself. We had AI inside the camera. We didn't have any extra components on top of the camera itself. And then we had a normal switch, and including the power over Ethernet capability to feed the power to the cameras. And we connected that with the Ethernet to the edge computer, what is also following this Industry 4.0 standards, and giving us possibilities to have more freedom how we can programming it and what kind of interfaces we can utilize. And then we utilized wireless communication, Wi-Fi, normal Wi-Fi, standard Wi-Fi to communicate the status information, what we are calculating on infrastructure side to the onboard system, what we have on a straddle carrier. And in straddle carrier, we had same kind of edge computer, what is making our state machine, and I will show what kind of state machine we made and how we made it. And as a user interface, we utilized a normal smartphone, and it was connected to the edge computer with the wireless Wi-Fi communication. As you have already heard in these presentations, that is quite easy to implement nowadays. It's easy to utilize as a prototype user interface. But on the left-hand side, we have a component called RTK GW, meaning that RTK, meaning that we are utilizing satellite navigation with the GNSS receiver on board, and that is including RTK, real-time kinematic features. So it is giving really precise and accurate position information when you have open sky and you have enough satellites available, and the constellation of satellites is good enough. And the gateway in this case means that we are sending the information to our edge computer and how it's collecting information. But also this proprietary component, we modified this component for this pilot and is capable to utilize these same standard interfaces introduced here. And why we have other extra components installed to the star carrier is that, of course, when you drive under STS crane, your crane, STS crane, is blocking your satellite view quite badly, and you are losing so-called fixed mode in RTK receiver, and your position information is not reliable anymore and not accurate enough to implement this kind of virtual geofencing features. That's why we implemented it so that we integrated the inertial measurement unit to this kind of satellite receiver. And then we also included wheel sensors to two wheels of the straddle carrier, and we integrated all those together with the wireless Bluetooth communication to make it simple really to retrofit also. What is different here compared to the previous versions, what we have also implemented and what other competitors have been implementing, what have changed recently is that the receiver, this kind of satellite receiver is quite much cheaper. We utilized some intelligent chips what are available in the market, and we based our component on those and build our system, and it is quite cost-efficient system and giving us many possibilities. Okay, on software side, you can see this kind of simplified communication flow diagram here, and you can see that our intelligent camera component is sending this kind of information that what is the status of the area, is it occupied or is it free? And we are also sending these kind of boundary events, meaning that if the guy is walking inside a virtual fenced area, we are sending an event to the system. And we are really keeping an inventory of the virtual geofenced area. So we are really calculating on how many guys and vehicles are inside the area and who are coming out of the area, because that is of course possible that you are standing in that kind of position that even camera can't see you, but we know that there is a guy, but we can't see that at the moment. And then we made this kind of simple state machine and how to keep control of the inventory inside the area, and how we send the information to the straddle carrier itself. And below you can see that what kind of information we are sending to the user interface, that we can really switch to the LED, for example, for the user, is it the green or red, indicating that this is the free or occupied area. And here is one example of how we programmed the system, because there are many ways in Industry 4.0 that to program this kind of systems, that this is called Node-RED, and this is this kind of graphical language, and it's really easy to see that what is happening in the system, and you can easily test the system, and you can build easily without any coding traditional coding methods. But we utilized also methods like model-based programming and other traditional ways and we combined all those together. And we really tested that is it possible nowadays, and how each platform is commercial platforms are supporting these ideas, and how the components like sensors, intelligent sensors are supporting these ideas. This is one example only about the library component. It is about MQTT broker and how we configured that one, and how to make it really easy for the user, for the maintenance guys, if something is had to be changed, that it's easy to change with this kind of user interface. This is a prototype user interface what we implemented to the mobile phone. On the top left corner you can see this LED, and below that one there's a simple map information only showing as a diagnostic information for the users, and where the machine is, and how the system is working. We have quite a lot of diagnostic information included to that one. And on the right hand side you have this kind of simple user interface, and you can even simulate this kind of system without having it installed to the real interface. That was only for testing purposes. And here is the environment where we tested the system, and of course when you are installing the prototype component to the real machine and to the real environment, you face sometimes some problems, but they were possible to fix. But as Kuro already explained, that because of the COVID time, it was not easy to get components and new installations made, and that took quite much time. We actually made free releases of these components because we found out that the first antenna, for example, Bluetooth antenna, was not good enough, and it was not omnidirectional antenna at all, and it was causing quite many problems, that the communication was broken, and of course it was affecting to the position information quite a lot. But we succeeded to fix those problems, and this is how it looks like in real machine, how we installed the component. This wheel sensor is, for example, simply installed to the wheel hub of the straw carrier with a few bolts, and that was easy. You can even utilize really strong magnet in some cases, that if can be installed in a really easy way as a retrofit project also. And on the top of the machine we have this antenna and the gateway unit, and you can see that we utilize the TIC communication, of course, how we communicate